In this section, we're going to look at something called the solubility of ionic compounds. Now, solubility is just a way of saying how much of a substance will dissolve if we mix it in water. If the substance dissolves, we get what's called a solution, which is a homogeneous mixture. What does homogeneous mean? Basically, that we can't tell the difference between the two substances. Salt water would be a good example of a homogeneous mixture. If you look at a glass of plain water and a glass of salt water after the salt's dissolved, you wouldn't be able to tell the difference. In these homogeneous mixtures, we have things called solvents and things called solutes. Solvents we've heard about, paint thinner, turpentine, things like that, but we're talking about water as being the solvent in these cases. Water is the solvent for what is doing the dissolving, and the thing that dissolves in the water is called the solute. So if we have sugar water, water is the solvent and sugar is the solute. Now we can deal with any phase, solid, liquid, gas, but for convenience we're only going to be dealing with liquids now, hence water. So we have two different situations. If the solute dissolves well, we call it soluble. And if it doesn't, we either say that it has low solubility or that it's insoluble. Now this would be the time to pull out the data booklet and take a look at the solubility rules chart. This is an easy, handy way to look at and look up what types of substances are soluble in water. The way we use this chart is we have to look at the compound and we have to look at the negative ion first. But in an ionic compound, the negative ion is always written second, so we kind of have to work a little bit backwards. Once we do that, we match up which positive ion it's paired with. Some will have a list and some will have all others. Then we just look across and see, is that soluble or is it not? So, example A, BaNO3(2). Now it doesn't matter that we have subscripts to show there's two nitrates here. It doesn't matter how many of them we have. That's just there to balance off the charges and balance the ionic compound. What matters is that we have nitrate paired with barium. So looking back at the solubility chart, nitrate is what we have to look up first. It's right here. And nitrate is nice and easy because essentially all, it doesn't matter which positive ion it's paired with, will be soluble. So barium nitrate is soluble. C, we have NH42CO3, ammonium carbonate. We need to look up carbonate first and then match it up with ammonium. Carbonate is right down here at the bottom. It behaves the same way as phosphates and sulfites. Looking at the list of ions, ammonium is listed, so we follow that across, and ammonium carbonate would be soluble. FeBr2, we look up bromine first, then match it up with iron. Bromide appears there. Looking at the list, iron does not show up in that list at all, so we're dealing with all others at this point, which would be soluble. I'm going to stop flipping back and forth. You can keep your data booklet out and look and pause as you need to match up. In G, we have calcium hydroxide, so we look up hydroxide, match it with calcium, and we find that that is insoluble, or low solubility. Just because of the amount of space I have, I'm going to write insoluble. Either insoluble or low solubility is perfectly fine as an answer. I, we have magnesium phosphate, so we look up phosphate, match up where magnesium fits with that, and we find that it is insoluble. K, we look up sulfate first, match it with nickel, that is soluble. M, look up iodide first, match it with silver, that is insoluble. O, we look up sulfide first and then match it with copper, that is also insoluble. Going back to the top, we look up sulfide first and then zinc, that is insoluble. Look up chloride, match it with lead, that is also insoluble. Look up sulfate, match it with silver, insoluble. Look up phosphate, match with potassium, that is soluble. Look up nitrate, match with ammonium, that is soluble. Look up chloride, match with aluminum, that is also soluble. Bromide, match with calcium, soluble. And P, keep in mind here, this is K2SO3. SO3 is not sulfate near the middle of the table. SO3 is sulfite at the bottom of the table. Match it up with potassium, and that is also soluble.